Hi everyone, welcome to this video where we will learn about Amazon MemoryDB for Redis. So let's begin with today's video, and before we begin with the topics, let me give a quick introduction about myself. My name is Aishwarya Sood and I am working as a lead coach into the AWS domain. I am 3x AWS certified, Amazon authorized instructor and AWS Academy accredited educator as well. You can connect with me on LinkedIn. My profile name is given here, Aishwarya Sood 29, and you can also scan the QR code to directly view my profile. So let me tell you about what are the topics that we are gonna cover in the today's video. So we will start with a quick introduction to a few Redis concepts, and we will then learn about what is MemoryDB, how it works, what are the core components in it, how do we set up MemoryDB cluster on the AWS console, few aspects about the performance of it, few use cases and the customer stories about MemoryDB, and a quick summary of whatever we would have learned in the entire session. So let's get started with this session. So before we begin getting started with the MemoryDB for Redis, it is important for us to understand what are the in-memory databases and what is Redis. I'll just give you a little idea about it. For a deeper dive in Elasticache for Redis or anything regarding this, you can refer to another video on the same channel, which is there with the name Elasticache Redis versus Memcached. So here in this video, I assume that you have a basic knowledge of in-memory databases, database caching, Redis and Elasticache. That would be really helpful in understanding the concepts that are explained in this video. So what is Redis? Redis is a fast open source in-memory key value data store. So for this purpose itself, I asked you to understand what are the in-memory databases. Developers basically use Redis to achieve sub-millisecond response times, enabling millions of requests per second for, let's say, for all the real-time applications in industries like gaming, ad tech, financial services, healthcare, and IoT. Also in 2021, Redis was named the Stack Overflow's most loved database for the 5th consecutive year. Redis offers the flexible APIs, commands, and data structures like streams, sets, lists to build the agile and versatile applications. Also, it has the support for advanced data structures. So it has got a lot of benefits along with it. So today we are going to discuss about what is this service of AWS, the MemoryDB for Redis. But why are we even having something like MemoryDB if we already have other options? Actually, there were some challenges with the in-memory databases, like they were difficult to manage, it is hard to make them robust, it is difficult to scale them, and they are too expensive as well. Now that's where MemoryDB has stepped in to solve these challenges. Let's see how it solves these challenges by providing us a lot of features. So the Amazon MemoryDB for Redis is a Redis compatible, durable, again the in-memory database service that delivers ultra fast performance. That's the keyword that you can remember for this. It enables you to achieve microsecond read latency, single digit millisecond write latency, and high throughput and multi-easy durability for modern applications like those that are built with the microservices architectures. This is a more sought out service for the microservices architectures because these applications require low latency, high scalability, and they use Redis flexible data structures and APIs to make the development agile and easy. Also, MemoryDB maintains a compatibility with the open source Redis and also supports the same set of Redis data types, parameters, and the commands that you are already familiar with if you are familiar with the Redis. This means that the code, the applications, drivers, and the tools you already use today with Redis can be used with the MemoryDB so that you can quickly build the applications. Also, very importantly, the main feature of MemoryDB that instead of using a low latency cache in front of a durable database, you can now simplify your architecture and use MemoryDB as a single and primary database itself, because earlier with Elastic Cache what we used to do, we place it in front of a primary database and it used to work as a cache. But now with MemoryDB, all your data itself is stored in memory, enabling the low latency and high throughput data access. Amazingly, MemoryDB is included in the AWS free tier as well, so you can get started with Amazon MemoryDB for free of cost. Beyond which, when the free tier expires, there will be some nominal charges. So how it works, what are all the things included in it? As you can see here, we have some applications, basically the microservices application, and here we have set up the MemoryDB for Redis, which is going to store our data in memory across hundreds of nodes that will eventually provide us ultra fast performance, and our application is directly using this itself for all the data. Now what is this multi-easy transactional log? MemoryDB will store your entire data set in memory, as you can see, and leverage a distributed transactional log to provide both in-memory speed and the data durability, consistency and recoverability. Let me elaborate it a little more. Like, there are a number of instances where MemoryDB may need to replace a primary node. These include certain types of maybe a planned maintenance and the unlikely event of a primary node or the AZ failure. What to do in that case? The response to the node failure will depend on which node has failed, and however, in most of the cases, MemoryDB ensures that no data is lost during the node replacement or the failover. For example, if a replica fails, the failed node is replaced and the data is synced from the transactional log that it has kept across multiple AZs. Node replacement may result in some downtime for the cluster, but if multi-AZ is active, the downtime is minimized, and multi-AZ on your MemoryDB cluster improves the fault tolerance as well. So what are these? I hope you have understood the little working and a few things about multi-AZ thing. Now what are these nodes that I was telling about, and what is this cluster? Let's discuss the core components of it now, so that we can understand those terminologies, the node, cluster, shards and all those things. So first thing, a node. Node is basically the smallest building block of a MemoryDB deployment and runs using an Amazon EC2 instance, and each node runs the Redis version that was chosen when you created the cluster for your MemoryDB. And a node belongs to a shard which belongs to a cluster. Every node within a cluster is the same node type, and multiple types of nodes are supported, each with varying amounts of memory. Now what are these clusters and what are these shards? Let's discuss them. Cluster is a collection of one or more nodes that are serving a single dataset, and a MemoryDB dataset basically is partitioned into shards, and each shard has a primary node and up to 5 optional replica nodes. Primary node serves the read and write request. Please note that, okay, primary node will serve the read and write request, but a replica only serves the read request. Now a primary node failover to a replica, primary node can failover to a replica node, promoting that replica to the new primary node for that shard. In case something has happened to the primary node, that can be failed over to the replica node by promoting it to the primary node. And MemoryDB cluster always has at least one shard. Now the MemoryDB cluster runs a Redis engine version, and each Redis engine version has its own supported features. The MemoryDB clusters can have up to 500 shards with your data partitioned across the shards. Like, let's say for example, you can choose to configure a 500 node cluster that ranges between 83 shards, where one primary node and 5 replicas per shard will be there, and 500 shards where single primary and no replicas. So this can be taken as one example, but there can be many cases. The main thing is that you should understand what are these cluster shards and the nodes, because this is a very basic terminology when we are working with the MemoryDB. Now apart from this, we have a few other components as well, like we have parameter groups, which are just to manage the runtime settings for Redis on your cluster, and are also used to control the memory usage, item sizes and more. Then there comes a subnet groups, which is a collection of subnets which are basically the privates that are counted and that you can designate for your clusters running in an Amazon VPC. Now when you create a cluster in an Amazon VPC, you can specify a subnet group or you can use the default one provided. MemoryDB will use that subnet group to choose a subnet out of it and the IP addresses within that subnet to associate with the nodes that you have created. Now what is this user? It is just having a username and a password, and it is used to access the data and also issue the commands on your MemoryDB cluster. That's it. So these were the core components of MemoryDB cluster, which will help you a lot when you are actually working with the MemoryDB. So we have understood the basics of MemoryDB, and it's the time to see how to set up the MemoryDB cluster and all the shards and nodes on the AWS console and how to connect to it. So we will see a demo quickly where just a small demo itself, where we will create a MemoryDB cluster. Then we will see how to grant the access into it using the security group rules, and how do we connect to this MemoryDB cluster. So let's go to the AWS console to see the demo. So here I am into the AWS console. Let's navigate to the MemoryDB. Let's search it here. So here we go, MemoryDB for Redis. So here we are into the MemoryDB console, and the first step that we have to do is to create a cluster. Within that itself we will define the node and the shard requirements. So here on the left navigation pane, click on the clusters option, and we just have to click on create cluster. Then we will define the settings and the requirements that we have. So before we go ahead with any settings, you can notice there are two options. First is to create a new cluster where we will define everything from scratch. Second is to restore from the snapshot, where if we have an existing snapshot, if we have taken it from an old cluster, we can restore the cluster from that itself. Right now we are gonna create a new cluster. So let's begin by defining the name for our cluster. I'll give it as my sample cluster, and that's okay. Description we can give if we want to give, but that's an option only. So right now I am leaving that. Then we have to choose a subnet group. We can choose an existing subnet group which it will show for our default VPC, or we can create a new subnet group. If we don't have a existing VPC in our account and we will have to create a new VPC, then the subnet group will be created, and for that the details can be mentioned here. But right now I'll go ahead with the existing VPC subnet group itself. That's fine for us. Okay. Only if you have a preference for any other VPC and you want to create a new subnet group, you can select the second option. Then moving forward, let the Redis version compatibility be default and the port also be default, which is 6379 as a default option. Only if you have a certain reason that you want the port to be different, then you can change, otherwise let it be default itself. Parameter groups also, which will be controlling our runtime properties, as I told you while we were discussing it on the slides. We can leave it as default or we can have another one, but right now I'll be leaving it as the default one only. Then I can select the node type, how much memory I'll be wanting. So I leave it as default db.r6g.large, which is giving me 13.07 GB of memory. Now how many number of shards do I want? Right now it is 1, but if I want high availability, it is recommended that I have to use at least 2. Okay, so but right now this since this is just a demo, so I'll not be defining more than 1. It is 1 is enough for me as of now. Then for the replicas per shard, do you want any replicas in each shard, like I was telling you about primary node and the replica node? Do you need any replica node? It can be anywhere between 0 to 5. Okay, because there will be 1 primary node and another 5 can be replicas, but it is up to you. Do you want a replica or not? So right now by default it is 1 and I'll leave it as it is. And if you have enabled specifically the multi-AZ, then make sure you have at least 1 replica per shard. Okay, then we will go ahead with the next option. Now coming to the advanced settings, what security group needs to be selected for our cluster. Now for this particular cluster I already have created a security group. I will show you what rules I have added into that security group. There's just one rule that is there. One second. This is a security group I created, and I'll go ahead and will show you the rules for this. So this is basically the security group that I'm going to attach to my cluster, and what it does is it allows the connections from the EC2 instance that I'll be launching, from which I'll be connecting to my MemoryDB cluster. So the rule that needs to be added here is just this: the 6379 port needs to be opened, then the source will be the security group ID of the security group that I am going to attach to my EC2 instance. That's it. No other rules needed. It is the only rule that you needed to add here. So I'll go ahead and choose this security group, and then encryption key you can say okay fine, with the default key itself we are okay. And encryption in transit, do you need or not? So I'll say no encryption needed as of now. And then snapshot also you can define what should be the retention period. Up to 35 days you can define for that. And do you even need the automatic snapshots or not? And if you need, do you have a preference for the snapshot window, that when it should be taken, that time you can specify all these things here. But right now, since this is just for demo purposes I am creating, I'll not be needing any snapshot, so I will disable this. By default it was enabled. Then for maintenance, do you have any specific preference of the time, that at what particular time that it should be performed or not? So I am saying no preference, and if I want I can specify a maintenance window. Do you want the notification for this or not? I am disabling the notification. Okay. So that's it. The main settings have been done. You can add a tag if you need. Other settings also you can change as per your requirement. This was just demo purpose, so that's why I chose with the basic settings only. Then I will create the cluster. Now it will take a few minutes for the cluster to become into the available state. As you can notice right now it is in the creating state. So if I open this, it is showing the creating state and the cluster endpoint is not there. We will have to wait for it to become the available state, and then the endpoint will become available. Then only we will be able to connect to our cluster from our EC2 instance. So let's wait for this to become available. In the meanwhile, we will go ahead and launch our EC2 instance, from which we will be connecting to our MemoryDB cluster. So I will go ahead and launch instance. I'll just go ahead with the Linux 2 AMI with all the default settings, because there is no specific requirement as of now. Instance details also fine. Storage, the default one is okay. Tags I can add here. I will say name, and this is the memdb EC2 or memdb instance. We can give that. Then configure security group. Now for EC2, what security group I am using? Please note the rules. I will choose an existing security group. I already have one, which is this web server SD. And what rule has been added here? Just the SSH. You can define the source as your system's IP itself. That's recommended. Okay. So just for testing purposes, I allowed all. So port range is 22, the type is SSH. Only this rule needs to be added as of current requirements. Later on when you will need more, you can add more rules here. But right now this is enough. So I'll review and launch, and let's launch the EC2 instance. Now let's wait for our EC2 instance to come to the running state. I'll just refresh and we'll see. It is right now in pending state, and soon it will come running. Till then let me refresh here and check if my cluster has become available or not. So no, it is still into the creating state. And let's check our EC2 instance. Yes, our EC2 instance is ready. So we can now connect to our EC2 instance, install all the necessary utilities for installing the Redis, and then we will be able to connect to our MemoryDB cluster. But we will wait for a few more minutes for this to become available. Then only we will connect to our EC2 instance also for doing the further processes. So let me pause the video here, and once it becomes available, then we will resume our demo. So after waiting for around 15 minutes, the status has come available. Now we can connect to our MemoryDB cluster. So this is the endpoint that we have to use in order to connect to our cluster. So I'll paste it here in the command that I have, using which I'll be connecting to my cluster. We will remove the port number because we are mentioning it here. So first, before we connect to our cluster from the EC2, we have to install the Redis CLI over our EC2 instance. So first we have to run these commands. So we will quickly go ahead, connect to our EC2 instance from the instance connect option itself, and we'll run these commands one by one so that we can install all the things. So then once all these commands are run, then we will be able to connect to our MemoryDB cluster. So let me run the next command also. Here we go, just few more commands, and we just have to change the directory here, and done. Just few more and it will be good to go. So let it process, and in the meanwhile let me check what command is left. Just one more command. So the command has been processed, and last command I have run. Now I am ready to connect to my MemoryDB cluster. So this command we have to use in order to connect to our MemoryDB cluster. Let me copy it and paste here. Yes, you can see here I am connected into my MemoryDB cluster. Now I can run all the Redis commands that I am familiar with, and I can use it for my data. Now it is set up entirely. Okay, so this MemoryDB cluster fully is set up. For this we have how many shards? Just one shard, within which we have two nodes, one primary node and a replica node. And here we are also connected into this MemoryDB cluster. So now this can be used further for whatsoever requirement we are having. So this was just to tell you that how you can set up and get started with your MemoryDB clusters. Now we will go back onto our slides and continue the further topics. So we have understood the MemoryDB basics, but if you understand the Elastic Cache also, so you might be having one question at this point, that how is MemoryDB compared to the Elastic Cache, because both services give access to the Redis data structures and the API. So what is the difference? Let me tell you about a few differences here. So MemoryDB, I would say it can be the primary database for your application, because it provides a data durability and microsecond read and single digit millisecond write latencies. With MemoryDB, you don't need to add a cache in front of the database to achieve the low latency you need for your interactive applications and the microservices architectures, which in fact you had to do in the Elastic Cache because this was not the primary DB. On the other hand, Elastic Cache provides a microsecond latencies for both reads and writes. It is ideal for caching workloads where you want to accelerate the data access from your existing databases. That is the main point here. And Elastic Cache for Redis is used to cache the data from other databases using Redis. MemoryDB is preferred for building application using Redis data structures and APIs with a primary durable database, okay, but Elastic Cache for the other. Also, another important point, MemoryDB can be used to simplify the application architecture and to lower the overall cost, because low cost is achieved by replacing the database with the cache, that is Redis. And as I mentioned, one more important thing, in MemoryDB, read after write consistency is there for the primary nodes and guaranteed eventual consistency for the replica nodes. Now, to summarize, MemoryDB will be a good fit for your use case if you want to build an application using Redis data structures and APIs with a primary durable database. But you can consider Elastic Cache for Redis for your use cases where you want to use the Redis data structures and APIs to access the data that is stored in a primary database or a data store. So that was the major difference between both of them. Now how about the performance? What are all the things that affect the throughput and latency? So the throughput overall and the latency will vary on the node type that you have chosen. Okay, like how we have chosen the node which was giving us 13.07 GB of memory, that will vary. Then the payload size that is going on, the number of client connections that are made to it, it will all affect the overall throughput and the latency. Less or more will be happening. It supports up to 390K read and 100K write request per second. That is quite huge. Also, it provides 1.3 Gbps read and 100 Mbps write throughput per node. And it delivers microsecond read latency, single digit millisecond write latency, and the read after write latency on the primary node for a cluster shard. That is a strong consistency. Okay, which means the changes are always reflected immediately. So these are few important points, few performance aspects that you should know. And now let's go ahead with the use cases for this. Because by now we have understood a few basics of MemoryDB along with the factors of like what impacts its performance, how it delivers us good features, and how it varies, how it differs from the elastic cache. Let's discuss a few use cases. So first is to build web and mobile applications. We can use versatile Redis data structures like all the things that I told you previously that are supported, like streams, lists and sets and all, to build the content data stores, chat and message queues, geospatial indexes for the demanding data intensive web and mobile applications that require low latency and high throughput. And then we can quickly access customer data for retail. So what does it mean? We can deliver the personalized customer experiences and also manage the user profiles, preferences and inventory tracking, and the fulfillment with the microsecond read and single digit millisecond write latency that the MemoryDB is giving to us. And also we can build the player data stores, session history and leaderboards for the gaming applications that require massive scale, low latency and high concurrency to make the real-time updates. Also, we can run high concurrency streaming data feeds to ingest the user activity and also support millions of requests per day for media and entertainment applications. Now I will show you a few things about the customer stories. One will be Netflix and a few more organizations which are using MemoryDB. So let's have a look about the Netflix. Who doesn't know Netflix? Right, we know what amazing services they are giving to us. So they say that our media platform uses a microservices architecture, so the point to be noted, and we are looking for the right database to support some of our platform requirements. We are excited about the launch of MemoryDB, which fulfills our need for a durable in-memory database that supports our short and long-term architectural plans. So you can see even the Netflix is using it. And then comes a Twilio, which is a leading cloud communications platform that enables developers to build, scale and operate the real-time customer engagement within their software apps via simple to use APIs. Now what benefit they have got? They say the director of engineering, that is Henry at Twilio, say that our platform sends and receives over 105 billion messages a year across voice, email, SMS, MMS, FB Messenger, WhatsApp and more. Now we need a database that can handle this high volume of messages while also maintaining low latency. So you can have a look here. MemoryDB is highly scalable, easily scaling to more than 100 terabytes per cluster. And as an in-memory database, MemoryDB provides the extreme high performance that's essential for our global platform. So MemoryDB has proven to be very useful for the Twilio as well. So you can read more customer stories on this page. Okay, I gave you 2 examples. You can read more on this page. Now we will summarize today's session. So to summarize today's session, let me give you the overview of what we have discussed so far so that you can remember the key points about Amazon MemoryDB. First, Amazon MemoryDB for Redis is a Redis compatible, durable, fully managed in-memory database service that delivers ultra-fast performance. It is purpose-built for modern applications, especially with the microservices architectures. Also, MemoryDB stores your entire dataset in memory to deliver the microsecond read latency, single digit millisecond write latency, and high throughput. It can handle more than 13 trillion requests per day and support peaks of 160 million requests per second, and that's really huge. And in addition to storing your entire dataset in memory, MemoryDB also uses a distributed transactional log to provide data durability, consistency, and the recoverability. MemoryDB will store the data across multiple AZs so that you can achieve the fast database recovery and the restart. Also, this can be used as a single primary database, not as a cache layer for the another primary database. Okay, and also MemoryDB clusters is a collection of one or more nodes serving a single data set. This data set is partitioned into shards, and each shard has a primary node, and up to 5 replica nodes can be there in the same shard. Okay, so you can scale your MemoryDB cluster to meet the fluctuating application demands horizontally by adding or removing the nodes, or vertically by moving to larger or smaller node types. And to migrate from Elastic Cache for Redis to MemoryDB, you can take a backup of your Elastic Cache cluster and restore it to a MemoryDB cluster. Like I was showing you the option for restoring from a snapshot. That thing is the same thing that I am talking about right now. And also we can create a new cluster, right, like how we did in the demo. And finally, about the pricing, with MemoryDB you pay for what you use based on on-demand instance hours per node, volume of data returned to your cluster, and the snapshot storage. Okay, so for more information you can also have a detailed look at the pricing page of MemoryDB about how you are charged for using MemoryDB. So that's all for today's session. I hope you have understood all the basics of MemoryDB. We will meet in the next video. Thank you.